show you did I give you the solution, explain why the bridge failed? You remember the skywalk? I never show you. Did anybody show you? I asked you all to think. Did you all manage to think? No. Okay, I'll tell you the answer later. So, what is free body diagram? It is the analysis of forces acting on the body. That is what mechanics is all about. It is analyzing forces acting on the body so that we can calculate what are the forces acting on the body. During lecture, I told you there are only 3 types of forces. What is the first one? External forces, internal forces, and reaction forces. Now, what are external forces? External forces are applied force. That means a force acting on you. That's called external forces. Here you go. So a force acting on you means external forces. In a problem statement, these kind of things are given. But you all push a chair, not push a chair. This is the applied force. Okay? Applied forces, do we need to learn? No need. It is in the problem statement. Second, internal force. What are internal forces? Well, it is inherent in the body, meaning it belongs to the body. Every body must have a mass. Agree? Yeah. And this mass will, and the CG will create a force called mg. Do we need to learn? No need. Because it's that you should know. Yeah? So what is the only thing that we learned last week? We only learned this thing called reaction force. Because in this real world, this body is not going to be in equilibrium. That's the key word we're going to learn tonight. This body is not going to be floating in the air with no support. You understand? It must be supported by something. It must be supported by something in order to remain in an equilibrium state. Right? So what we learned was, we learned how to analyze reaction forces. Yeah? And what did I teach you? Well, let's go back to your notes. This is what we went through. This is a moment to me. Okay, we want that. These are what we went through last week, right? Okay, now. Again, 3 types of forces. What are those forces? External, applied forces. Internal, which is mg, and reaction force. What do we mean by reaction force? Since this is a revision, I'll go quite fast. Reaction force means what? Reaction force comes from where? From the support system. Imagine you are the body being supported by such a mechanism. Imagine you are the body. Imagine you are the body lying on this roller. What did I teach you? I teach you that within your hip. X, Y, and moment. You need to identify your reference frame first. Ask yourself, can you move in that particular direction? If you can move, any reaction? No. No one. So, you as this body now, can you move in the X direction? Can, right? Any reaction force? No. No. So, no Rx. Clear? Can you move in the Y direction? No. No. Good. So, there must be a Ry. You understand? Yeah? Look at here now. Say you are this body resting on this mechanism. Can you move in the X? Yes, because this is a roller. Can you move in the Y? No, there must be a Ry. Can you rotate? Can. It's a pin joint, free to rotate. Any reaction moment? No. Clear? That's why you see the answer is all here. This is a rocker, same logic. Can move in the X? Can, because it rocks. Can you move in the Y? Cannot. Can you rotate? Can, so no reaction moment. Then I told you, inclined plane, immediately you rotate your reference frame in this direction. Can you move in the indicated X direction? Can, so no reaction. Can you move in the Y direction? Cannot, so there must be a Ry. Can you rotate? Can, so no reaction moment. Yeah? Then we might move on to smooth surface, same logic. X, Y, and movement. Can you move in the X? Smooth surface, can move in the Y, cannot, Ry. Clear? So same, once you see incline, rotate your reference frame. Ask yourself, can this body move along the X direction? Can. So no reaction force. Can move in the Y? Cannot. So are what? Perpendicular to the incline. Remember that. Because your reference frame is already aligned to the inclined plane. Can I? Then I told you, cable and rigid link, they are the opposite. A cable is used to what? To pull for tensile force. Cable always equal and opposite. Because it's used for tensile, that means you always use it. It's in tension. It's never used for compression. Have you seen a chain link using a string? No, it doesn't make sense, right? Because a string or a cable is used to be pulled, not to be compressed. So, same goes for a rigid link. A rigid link is to be subjected with a so-called compressive force. This one you have to understand first. Yeah? Yeah. Cable is to pull, so it's equal and opposite. If you chop the cable into pieces, you analyze the force inside, it is still equal and opposite. Same goes for rigid link. Rigid link is the legs of your chair, legs of your table, etc. It is used to withstand compressive force. So the forces are inside. So how do we analyze this? Simple. I told you, free body diagram is to imagine yourself as the body. So now imagine yourself. Let's look at this example. Imagine yourself as the body. Your hair is being tied to a string which is tied to a ceiling. How do you feel? You feel very painful. Where does the pain come from? Your hair being pulled up, right? There you go. This is how you feel exactly. Can you relate that? You must imagine you are the body. Do you understand this? Okay. Now imagine you are this body now. Your legs are being tied to the string and attached to the thing. So you are hanging mid-air with your legs tied to the string. How do you feel? You feel that there's a force. There's a force through. Do you understand? Understand? This is the force. Yeah? Yeah? This is what free body diagram is. Now, same thing for rigid link. Just now, you notice all the forces are away from you because it's pulling you. Yeah? So now, imagine now, you are the body here, or your friend lie here. And just imagine. So your hands are pushing him with your legs 45 degrees to the wall. How would you feel? You feel that your hands are withstanding the force, then your leg also withstanding the force. So this is the reason why you have the force acting into you. Imagine this is you. Logical? Can you relate? Yeah? So now, imagine you're the friend now. Okay? You're lying horizontal, but your friend below you is supporting you. How you feel? You're on your back. You feel someone pushing you up, right? This is exactly why the reaction force is this direction. Clear? Yeah? Yeah? Okay, so far? Okay, now, same thing. Hinge joint, we went through last week as well. Hinge joint, same logic. Exactly the same logic. I'm repeating all these things. So, let me know if you understand. So, hinge joint, same logic. You are going to analyze it now. X, Y, and moment direction. X, Y, and moment. So, imagine you are this body, pin at that joint. Can you move in the X?
No.
No. Rx. Can you move in the Y?
No.
Cannot. Ry. Clear? So, same goes for this example here. It's the same. Nothing changed. It's free to rotate, that's why no reaction moment. Okay, now, at this point, I was asking you, right? Does it matter I draw this way, or can I draw this way and this way? Can. It doesn't matter. I told you. All it matters is you must draw the right number of reaction force. This kind of support system, 2 reaction forces. Clear? Or if you cannot, if you draw 1 reaction force, everything gone. Because this support system has 2 reaction force. This is where your contribution is. This is the key to chapter 2. You can't draw the right free body diagram, whatever you're going to do later tonight. It's all wrong. Clear? Yeah? So make sure you know how to analyze. Same thing, now imagine yourself as a pulley, your head. Someone put a rope around your head, right? Someone is pulling a rope up. You pull like that. How would you feel? You feel someone is pulling you So this is where your two tension is doing to your head. Or imagine you are the head. Yeah? Okay? So that is for applied force onto you. So you are supported by this pin joint. Pin joint again. Can you move in the X?
No.
No. That's why you have a RX. Can you move in the Y?
No.
Alright. Can you rotate? You
Yes.
can. So no reaction moment. Clear? Yeah? So this one is the same. Just that now it's called rough surface. What happens when you have rough surfaces? It means that you are not free to move in the X direction. Rough surface mark of friction. So you have a RX. Yeah? Can you move in the X? Cannot, because you have to overcome friction, so it's RX. Can you move in the Y? Cannot, RY. Clear? Can you rotate? You can. So no reaction moment. Yeah? Yeah? So inclined surface, immediately you know that you must do this. Or can you move in the inclined X? Cannot, because of friction, so RX. Can you move in the Y? Cannot, so RY. Okay? Still with me, right? It's still the same thing. Last but not least, this is the fully constrained body. Why? Because this body is fully constrained in the X, Y, and the moment direction. Meaning, just imagine yourself, your head is stuck into the wall. Can you move X? Cannot, RX. Can you move Y? Cannot, RY. Can you rotate?
No.
No. So you have a moment. This is the maximum number of reaction forces acting on such a support system. Yeah? Just like the lamp being secured to that joint there, you can't move X, you can't move Y, neither can you rotate. So maximum. Yeah? Yeah? Okay, so far. Good. So that was what you learned. And let me summarize here. Guys, so this is what you learned, and you have come so far. So tonight you wrap up your chapter 2. You have a body, you know how to analyze free body because the external force, internal force, and what you learned just now was reaction force. Yeah? This is known. This most probably is known. Do you see something? You realize that, oh, these are unknowns. Agree. So how are you going to find the unknowns? Okay, so that's what we're going to learn today. Yeah? How do we find the unknowns? Now, okay, just since we have the time,